Hello, my name is Diana Collins. I am the Product Manager for Magnitude MDM and DIW, and our topic today is Business Modeling Concepts and Techniques. So today we'll be discussing some general concepts in modeling in MDM. Then we'll talk about some specifics around hierarchies. We'll talk about associations in general. Associations are a very key part of our approach to modeling. In particular, we'll talk about one-of associations and how those handle ragged hierarchies, and some discussion of map CBEs, a particular feature of DIW, and then we'll wrap up with a summary. So let's jump right in. Let's talk a little bit about some of the general concepts. So in MDM, we have these things called domains, categories, and associations, particular one-of associations. So those are peculiar concepts, or particular concepts to MDM. In DIW, we have things called dimensions, CBEs, classes of transaction, and transaction data sets. A lot of them are visualized in the screen very similarly. So for example, a domain and a dimension are similar concepts and are visualized similarly in BIM, the Business Information Modeler. So those tan boxes of customer, product, time, and internal organization, if this is a MDM model, those things are domains. If this were a DIW model, they would be dimensions. Within each of those, we have categories in MDM and classes of business entity, or CBEs, in DIW. The modeling environment looks very much the same and functions very much the same. Really, the only significant difference is the lack of transactions in MDM models and their presence in DIW models. So there are a couple of terms that are specific to the discussion, so let's talk about this a bit. So first definition of terms is involution. Right, so an involution is basically just a recursive relationship that's applied to a category. As you see, it's how we manage things like ragged hierarchy. Referential integrity is simply a test that's made between a child and a parent category of information to make sure that where a parent is mandatory, that parent is in fact supplied. We go a little bit further in referential integrity in that not only do we verify that a parent is supplied, but that the value that's supplied for the parent is a valid value and that that specified parent actually exists in the parent category or table. In MDM, we refer to categories of information. In DIW, those categories are simply called classes of business entity, reflecting the evolution of DIW from a more object-oriented kind of environment. We'll also talk about ordinality and cardinality of associations in MDM and DIW. Simply defined, ordinality is whether something is optional or mandatory, and cardinality is the number of allowed members in that attribute or association. So associations have both ordinality and cardinality. We will see that some associations are optional, some are mandatory, and they also have cardinality. They can be one-to-many or they can be many-to-many. And if they are many-to-many, we can set min and max occurrences of those associations. Right? So, and they're displayed somewhat differently in the modeler. Optional associations, what you see at the top of our screenshots there, of a parent and child association, they're shown as a dotted arrow. If the association is mandatory and a one-to-many, then it's shown as a solid single-headed arrow. If the definition of the association is mandatory and many-to-many, then it's shown with a solid line and two arrows, a double-headed arrow. So the arrow is indicative of whether this is a one-to-one or a one-to-many. So associations have other properties besides ordinality and cardinality. There is the label. So the label is the name that will be shown as the prompt when you're looking at a child record to have you select the parent, the appropriate parent, when the record is being entered. Parent and child role. Those roles must be unique across a given category of information. So if I have 3 associations, for example, that connect a parent category to the child category. Within the child category, the child role must be unique for each of those associations. Likewise, on the parent, if I have multiple parent associations, those have to be unique within that category. Drill down label is the prompt that is shown in the parent to drill down, that is to drill through to its child records. Check boxes available in here, so there are a number of those. I'll mention a couple of the key ones. Display children in line, so that's as opposed to creating a drill down field, right? So displaying the child records in line, instead of there being a link, we'll actually read those child records and display them in a large attribute box in line with the rest of the attributes of the parent. Display parents in the drop-down box. So if I were entering a record into the child category, do I want to simply be able to select those parents from a drop-down box, or do I want to have a link that opens a little search dialog where I can find the parent that I'm looking for? Generally speaking, the guidance here is the number of parents that are available. If you have a parent category that's going to have 15 or 20 subjects, then that's a good candidate for a drop-down box. It's going to be significantly more than that. You probably want to have a pop-up and be able to scroll through and search those parents. And then the display checkbox allows us to determine whether the contents of this association, that is the value at the other end, is actually displayed in lists and baskets when I look at this category. So if I'm looking at a category and it has a number of references to parents, do I actually want to show the parent values when I look at the record in a list? So that's what display would control. And the Web API ID is the object name that will be used in the Web Services API. So you want to do something that the developers will be able to use and understand easily. Attributes also have properties, of course. Key ones, data type. So here we can select whether something is text or a URL, or whether it's numeric or an integer, etc. This is actually validated during loading. So if you tell us that a particular attribute is supposed to contain only integer data and it receives an alpha character, that alpha character will be rejected and the record marked as invalid. And we can also include format in this. The format field basically contains an edit mask that defines how the field is to be formatted. That is applicable to text fields. And we also have some special handling fields like numeric ranges, where we specify that there are actually 2 values where you provide both a min and a max, a period of time where there's a start and an end date, and one of attributes where we specify the list of actual values that are valid for that particular attribute, and those values become part of the model. So it's sort of like embedding a small set of data in the model itself. Again, that should be used only for very limited numbers of possible values. We can also auto-generate, as you can see in the upper right here. We can auto-generate codes. So we can specify that we want to automatically update the sequence every time a record is created. And we can also specify that there can be no manual entry, that the automatically generated value must be used. And a couple of things involved here. One is setting off the mask. So in this case, we're saying that all of our codes will contain the letter CA followed by a number. If we wanted the letter to also be a variable, we could enter a placeholder for that as well. And then we enter in what we want to, what in that mask represents the variable. So in this case, it's the hash mark. And the variable section is going to be a number starting at 999,000, or up to 999,999. And then then that automatically populates the lower value and the upper value. And so you can change that if you wanted the lower value, for example, to start at CA00001, we can do that. If you wanted the upper value to be something short of 999,999, you can do that as well. And the same sorts of things we saw in the association checkboxes for display. And will we display this value in list searches? Is this a read-only attribute? Should we use it for data matching, etc.? Right? Is it to be used for lookup? So hierarchy types. Hierarchy management is a key component, particularly of MDM, and a number of different hierarchy types are supported. So first is what's referred to as a full hierarchy. A full hierarchy is any hierarchy that has a single root and has the same number of levels as you go down. So there's always one node at the top of the hierarchy. The hierarchy then can have any number of children, grandchildren, great-grandchildren, but every path is going to be the same length. Right? So here we have, in these examples, we've got lots of variations in the hierarchy, but every single one of them started with a single node and ended up with 3 levels of node. Another very common type of hierarchy is the unbalanced or ragged hierarchy. In these cases, not every path is the same. So here we have some hierarchical paths that are 3 levels deep, others that are 2, and in some cases only 1 level deep. So that's an unbalanced or ragged hierarchy. And then just to be complete, there are these things called binary hierarchies. Binary hierarchies is a sort of a special case of full hierarchy, where there are 2 root nodes, 2 nodes at the top of the hierarchy, and every level of the hierarchy has 2 nodes. So the parent each have 2 children. Each of those 4 children each have 2 children of their own, or grandchildren of the root, etc., etc. Again, same number of nodes down the path, down any given path, but with a unique provision that each node has only 2 members at that level, 2 nodes at that level, and every node has 2 and only 2 children. Regardless of the hierarchy type, they are supported in both products, but there are some variations in the way some things are handled. So, for example, we have these things called one-of associations in MDM. These do not exist in DIW. They allow a subject to have one of 2 or more parents. So these can be used in place of an involution when you want to enforce mandatory involution, that is, every child must have a parent, and allows you to get around the problem then of what you do with the top-level parent. You simply associate it to a parent category to hold the top-level parent. We'll see examples of this later when we get into a demo of the modeler. There are also some DIW-specific association properties. These mainly exist because in DIW we're rolling up facts, and so there are some special cases that we need to deal with in the aggregation of fact data. So simplest is non-aggregative, simply says that that association path cannot be used for summarization. We will not summarize across it. We will use it for grouping only. Principal path, so when I'm drilling down through categories, what is going to be my default drill down path? And if I'm aggregating data, if I don't specify a roll-up path, what is the default roll-up path? Cut associations, so if more than one path exists, I can cut a path if I do not wish it to be deployed to the dimensional table. Simplifies the content of the dimensional table where people are not going to be drilling down across the association. And then finally, a dimensional set simplifies aggregation when we have many-to-many associations. DIW goes to great lengths to avoid double counting. And so many-to-many associations are generally avoided in DIW because of the complexities involved in calculating basically the Cartesian product of parent and child nodes across many-to-many. So instead, what we can do is we can say, okay, instead of doing that exhaustive calculation, let's define the many parents as a dimensional set, which is basically the same as saying they're non-aggregative, but allows you to be non-aggregative across multiple multiple parent categories, whereas a non-aggregative association is applied to one category at a time, one particular association between a parent and child category. Okay, so I mentioned involution before. It's as being simply a recursive association assigned to a pair of categories. Data is loaded in parent-child pairs. It makes it very, very easy to deal with these kinds of ragged associations. So whether we're working in MDM or DIW, when we come to load the data across an involution, we simply give it the parent ID and the child ID, and the product, whether it's MDM or DIW, calculates how many levels deep the hierarchy is at maximum, creates a table with that many rows, and then normalizes out the paths as required, depending upon the product, with default values. And so in DIW, that means populating things with things like not classified at this level as default values. Coding structures in DAW or one-of associations in MDM are a special kind of grouping. They're used to establish a link between a given category and another classification category where that category may have some structure within itself. So it's sort of like a subtype, where you have a supertype and a number of subtype classifications within that, but those subtypes have a set of relationships between themselves. So this is useful for things like geography, where you may have customers, for example, and some of which their geography is resolved down to the city level, and in other cases it may only be resolved to the regional level. Or you may have industries that you're mapping to a a standard industry classification structure, like the North American Standard Industry Classification Structure, or NAICS, and where you may have some customers that fall in at the 4th or 5th level in that hierarchy, and others that fall in at the 2nd or 3rd level in that hierarchy. And allows you to support that with a single association instead of having to have multiple associations to every single level in the NAICS hierarchy. Okay. Lots of applications for it. We'll see a couple examples when we do a demo later in the presentation. So visually, one-of associations, for example, in BIM look like this. You draw first a normal association, and then you select the association properties, click a button that's labeled Allow Multiple Parent Classes, and then you're allowed to draw any additional parent classes as required. So it can be used one of two ways. In this view, what we're seeing right here, it's with using a parented involution. Right? So this would allow you now to have all of the involuted relationships be mandatory, and have that top level of the involution, which would normally be an unparented node, or unparented subject, instead have a parent that's simply in this other parent category. Right? So allows you to have referential integrity enforced across your involuted association, across your ragged hierarchy. The other way to use it is alternate parent categories, where you may have, for instance, a child category that can be, for instance, a customer that can be classified as either an individual or as a corporation. And you want to have that association exist to one of those two parents. And so, again, we simply draw the first association, draw the second. And you'll note that once we have these multi-parented associations, the label of the association is shown in the association in a little bubble on the association line itself. Those hierarchies display themselves a little differently in DIW and MDM. We have this sort of branching tree paradigm in DIW, whereas MDM we have a set of nested bubbles or nested tabs within a hierarchy. And also worth noting that in MDM we can reclassify within this hierarchy browser. So it's really a hierarchy manager where we can move data between nodes of the hierarchy. So as you can see in the example shown here, we've reclassified satellite telecommunications from its own subgroup into the wired and wired telecommunications subgroup. Another unique concept in our modeling is this concept of a mapped BE. Allows us to link dimensions together to form, or subsets of those dimensions to form demographic or sort of mapped combinations between those dimensions. So, examples are exactly that, linking customer demographics and products, for example, to create a target market definition. You define the selection criteria for each dimensional object, so I select out the particular, in this case, product subgroups that I would want, and BEs are created dynamically by DIW for each of the specified combinations of, in this case, product and demographics. These are then stored in a virtual mapping table. Not that the table is virtual, it's that the dimension that it represents is virtual. It's a regular mapping table like any other, and can be extended just like any other. But it refers to a dimension that is virtual and is defined as a combination or subset of a number of other dimensions. And then finally, before we do a brief demo, let's have a brief discussion of customizations. So custom validations in MDM can be written in either VBScript or SQL. SQL is generally much more efficient because it executes in the database server, whereas VBScript requires returning data to the app server to execute the VBScript. Workflow exits can be called from workflow. They can be written in any .NET compatible language. The resulting DLLs must be registered with MDM and assigned a name, and then they're called by name from workflow. And of course, there's MDM Workbench, the ultimate customization tool that allows you to design custom screens, build MDM apps that will present data in a defined business process. So it allows you to augment the workflow within MDM with a business process workflow to link together a specific set of screens and processes and actually define a business process within your MDM application, thereby combining the best data and the best process for the best result. So let's take a quick look at the product. First up, we'll take a look at MDM and how we can use one-of associations. So remember, here we have an example of a customer that we want to group into either the fact that they're an employee of a corporation or the member of a household. So how do we classify that way? So we draw a line first from the customer to the corporation, and that is telling us that this customer could be employed by a corporation. However, we also want, as I said, to have the possibility of this customer being a member of a household instead of being employed by a corporation. Well, that's fine. We just come to the association properties, and we click this button, allow multiple parent classes, and you see we get the label in a bubble. We can then add a new association from that bubble to the household category, and now this association is defined as being the customer can be classified by either corporation or household. At the moment, this is still mandatory. This is still optional, right? But we can make it mandatory by selecting the association itself and declaring it to be a mandatory relationship. And you see they all convert to mandatory arrows. Okay. As also mentioned earlier, another way of handling involutions involves using one-of associations. So here we have a case of we have an involution. What we want to have an involution on our employee category, so employees report to other employees. But ultimately, we get up to the top of a division, and at the top of that, we only have the executive for that line of business. and they have no manager. So how do we deal with that? Well, we can deal with that using an as-of one-of association, right? So we draw from employee to the executive. We allow multiple parent classes. And now we draw the new association instead of to a third category, we draw it back to employee. And again, we can make this association mandatory. And now we have can employ referential integrity so that all of our employees are managed by either another employee or a member of the executive committee, thereby solving our involution, our mandatory involution problem. All right, so now let's take a look at DIW and the way we can create classifications and what we refer to as a coding structure. So I mentioned they can be used quite simply in geography. So imagine we have a supply chain dimension that contains the distributors. And our distributors are assigned territories in various geographies. Some distributors are assigned cities, and some are assigned countries, and we even have a distributor or two that handle entire geographical regions. So how do we represent that? Well, we could draw associations to each and every one of these, but they would then all have to be optional associations because we can't have a distributor that handles both a city and a country. What we can do, however, is we can create roll-ups so that each city has an association that rolls it up to a country, and each country rolls up to a geographical region. And then we can take our draw an association between our distributor and geographic coverage as a whole. So now what this is telling us is that what we actually have here is a coding structure, and that this coding structure says that a distributor will have an association to something within the geo coverage category, but we will go and search across each of the members of geo coverage looking for either the city code, the country code, or the region code. And so that could be very, very powerful, and there are lots of ways this can be used. This is just one example. Anytime you have the problem of a category of information being associated with many other categories of information that have some kind of a relationship within themselves, consider using them as a coding structure. So the final thing we wanted to look at is, in terms of the modeling techniques, is a mapped BE. Right, so let's look at, for example, as if we want to create a mapped BE, creating some target markets between that consist of a particular geography, perhaps a particular group of clients, and perhaps a particular set of products. So how do we create that? Well, first we would create a category of information, a CBE in DIW terms, and a dimensional group called target markets, and a CBE called market. What we then do is we make this a type and a mapped class of business entity. So by default, classes are normal. We can make them periods of time, currency, etc. But what we want to make this one is a mapped class. And then we can start drawing associations. So we want this to consist of geography. So let's say we are going to use geography at the city level. We could, of course, use it at the state level, or we could use this coding structure itself. So map that in, and we simply tick the checkbox down here to say that this is a mapped association. We do the same thing for our products. We draw the association to from product to market, and we mark that one as mapped. And then finally, we draw the association from client to market and map that one as mapped. When we deploy this model now into DIW, it will create a new dimension called target markets. This will be a virtual dimension with a virtual CBE within it called market. And market is then defined within DIW. Each CBE in the market code is defined within DIW, assigned a name and assigned which geographies, which clients, and which products from the list that are available in each dimension we want to put into this particular market. And I can drill up the hierarchies and choose and qualify my list by any of the parents in those hierarchies. So I will see my full list of products, but I can group them by subproduct, by group, and drag an entire product group or subgroup into this market and make it part of the market. Likewise, I could do it by packaging, by product class, by supplier, by anything by which product is classified. So it's a very powerful way to create these kinds of dynamic markets. They can be made, unmade, they can overlap, they can be exclusive, they can be any combination of the attributes that you require, and create very targeted markets, and then use them just like any other classification in MDM. I can roll up any fact that links into any of the members of a market by their market. And it can be some very powerful analysis for marketing and distribution. All right, so now that we've taken a look at some of those concepts in action, there are a couple of things just to cover. In summary, some modeling guidelines. So one of the key things when you're creating a model in the business information modeler, whether it's for MDM or for DIW, is to keep in mind what is the goal. What is it that we're actually modeling? And in most cases, what we're modeling is the business, not the data. We want to understand how information is consumed and reflect that consumption of information in the model. Don't model how the data is stored in the source, model how it's going to be consumed, and let the application define the physical model that best represents those concepts. You really want to define the key business concepts, the formulas, understanding what we mean as an organization when we say customer. Or do we consider vendors to which we also sell something a customer, or are they more vendors than customers? Do we have special types of customers? And that's really when you start thinking about how you have attributes of customers, and maybe they are really classifications of customers. Right? So if we have customer types, maybe those aren't an attribute of a customer. They're not something that is innate to the customer itself. It's a way we classify groups of customers. Right? Valuable customers, high profit customers. All these things may vary over time and are best handled as classifications rather than as attributes. You can use one-of attributes to actually embed a small number of values within the data itself. For example, if you have products that only produce, say, only have 5 colors, well, rather than creating a separate set of data records for each of those 5 records, for each of those 5 colors, you can insert them as one-of attributes within the model itself. So have red, blue, green, yellow, and white, if those are the 5 colors, be the only possible values and have that embedded right into the model itself. Now, obviously, other demographic things like marital status, gender could also be candidates for one-of attributes within the model itself. And those are supported in both MDM and DIW. And then finally, we really recommend using the description and help text attributes within the model to give context and explanation to the model, so that when the model is looked at by someone else down the road, there's some explanation of the thinking that went into the definition of each of those model concepts and elements. Okay, I'd like to finish the presentation with a quote from John Nesbeth, an author and a scientist who said, "We are drowning in information but starved for knowledge." And that's very, very true. That's really what I believe both master data management and data warehousing are designed to address, is the conversion of information into knowledge. and the ability to inform as well as report. And I thank you very much for your kind attention.